Hello, welcome back to the channel. In this lecture series, we've been discussing about different sensors that are available in the recent cars. So, in this video, we'll discuss about crash sensor. So, crash sensors, these are like currently the guardians of the autotronic safety, where like the automated cars, these involve the crash sensors so that it gives extra safety to the occupants within the car. So crash sensors, these are critical for the occupant safety and also for the vehicle's integrity. This is currently a market of like $5.8 billion. It projected towards like 2030 with like a 6.5% CAGR. So they are very essential for the safety of the vehicle as well as the occupants within that. So this involves something like airbags, e-call, and so on. So why is this important? What is the need for a crash sensor? So it has been estimated that there are like 1.35 million global fatalities, like that is around 1.35 million people. They face they face road accidents and they are killed by that. And the injury reduction because of the implementation of this crash detection sensors, it can reduce it around like 20 to 30% when these crash sensors and thus the deployment of airbags. Around 20 to 30% of these fatalities can be reduced, and even the injuries can also be curtailed. So these sensors are mandated by regulations like FMVSS 208 in the US and ECR 9495 in the EU. So these ensures safety standards in the automotive industry. So what are automotive crash sensors? There are different ways they work. The first thing is like electronic detection. First thing they do is the devices detect rapid deceleration of the our impact forces. So when there is a crash, what happens is the acceleration is correct. The acceleration in the opposite direction happens very fast. Thus, the rapid deceleration with the MEMS integrated sensors and the IMUs and so on, these will detect there is a rapid deceleration, and most probably it is because of a crash or sudden brake being applied. So this sensor millisecond impulse, the millisecond response, they trigger a passive safety systems in milliseconds, and typically around 15 to 30 milliseconds the airbags will receive a signal, and this signal will be converted to mechanical force, that is the airbags will be deployed to protect the person or the occupants within the automobile. How crash sensors operate? So there are different ways through which they work. The first one is MEMS accelerometers. So these are the most common ones that are used. So they use detecting G forces in multiple axes. So MEMS accelerometers work in like X, Y, and Z axis. So deceleration in any one of the axes can be identified by these sensors. Then there are pressure sensors. So these pressure sensors are located in the side doors. So sensing a pressure change will intimate the electrical control unit that there is some impact on the side, probably for T-type collisions and side-on collisions and so on. Followed by that, we have piezoelectric sensors where they detect deformation and stress upon impact. So whenever there is a change in the structural integrity or whenever there is a deformation or stress applied on the mechanical body, the piezoelectric sensors applied on that will deform and thus send a signal impulse. And then all of these sensor data will be processed together. Data processing will be done. These signals will be sent to airbag control unit, that is ACE, for analysis, and then the airbag will be deployed. So what are the key applications and impact? So the first thing is the airbag deployment. So whenever there is an impact, the airbag will be triggered within milliseconds, and the airbag's deployment will be around like 10 to 15 miles per hour equivalent. The deployment rate will be around 10 to 15 miles per hour. Followed by that are seatbelt pretensioners. So the first one, the airbag deployment prevents the face portion of the occupant. Then comes the seatbelt pretensioners. Even when there is airbag deployed, maybe because of maybe a slight change in, slight delay in the deployment, The seat belt might become loose and the person might fall off through the dashboard, or maybe like the occupants in the back, they might get hurt by the seat in front, or might be defenestrated through the windshield. So in order to avoid that, the seat belt will be pre-tensioned. That is, the seat belt will be tightened so that the occupant are tightly fastened within the seat. I mean, within the area there where they are seated. Then comes the automated e-call system, where it dials the that particular country's or that particular constituency's emergency number, 112, 911, 100 for India, 108, whichever is mandated by that particular region. That number will be called, and then an automatic call will be sent for emergency. Followed by that as ADAS integration. So these are the previous ones are portion of the ADAS integration. So what it does is it integrates the pre-crash data for automatic emergency braking. So it tries to predict when there might be a scenario where there is going to be crash, or it might also prevent when there is going to be crash. So it might apply automatic emergency brake so that crash may be avoided, or maybe the situation might be, the intensity might be lessened. So the market landscape and key players. So the major players in this industry are Bosch, of course. Then we have Continental, ZF, Sonata, and Infineon. The market leaders are, of course, North America, USA, and Canada, and then, of course, we have Europe. So these are the market leaders, as well as because they are market leaders and pioneers. The countries and the European Union, they have adopted strict safety standards and use these to incorporate in the ADA systems. So the growth drivers are autonomous driving and active safety systems, which drive the market's growth. The future of crash sensing is that sensor fusion, that is a combination of the radar system or LiDAR system along with the camera, physical sensors. All of these can improve the accuracy of predicting the imminent crash that might happen. And AI or machine learning can also enhance the prediction by understanding the situation around the vehicle. And V2X communication is not V2X and V2E communication. Since information between vehicles and the nearby like Internet of Things around that, so that it can understand the objects that are in front of it, or if there is any obstruction. So it will identify what sort of obstruction it is, maybe if it is static or dynamic, understand that, and then maybe get like pre-crash data so that it can act accordingly. Then we have solid state sensors, the smaller and more robust sensors, which are cost effective for future vehicles. So to conclude, driving towards safety roads by these automatic systems, ADAS and crash sensors. So the first thing is occupant protection. The crash sensors are foundational for occupant protection. Then we have continuous innovation because of the continuous innovation towards automating the automobile systems. So continuous innovation is crucial for achieving vision of zero fatality goals. Then we have future integration. The integration of evolution of autonomous and connected vehicles is one of the driving factors towards the, I mean, continuous improvement.